Number 6 is based around a fairly simple picture right here. There's a current here that's traveling counterclockwise through a loop of wire, and there's a magnetic field inside the wire. Now, careful inspection of the problem, this I here is actually the induced current, so this isn't being put on by any particular battery or anything like that. It's an induced current, but of course an induced current comes only when a magnetic field is changing, and so this problem is asking about that change. In particular, is this magnetic field, is it increasing in strength, decreasing in strength, or is it staying steady? Okay. Now we know it's not going to stay steady because of all the things that we sort of been discussing here. In particular, that EMF here depends on the changing magnetic flux being not zero. Electromotive force is proportional to the derivative of the magnetic flux. If the magnetic flux is a constant, the time derivative of it is going to be zero, and there'll be no EMF and no current. So we know the answer can't be steady. So the question is it increasing and decreasing? Is the magnetic field increasing or decreasing? So you look carefully and go, okay, well, if the induced current is counterclockwise like this, what that means is if I put my thumb in the direction of this current right here and curl around, I'll come under this loop of wire up. It looks like the magnetic field, due to this induced current, is up inside in this interior of the loop. Hope you can agree with that there. Looks like the magnetic field is up. So if the induced current feels compelled to produce an upwards magnetic field, what that tells me then is the magnetic field inside the loop must be decreasing down like that. And that will be the answer to this problem now. But the question is why? Why would it be decreasing down? Why would these red arrows be getting larger? Well, if the induced current is up, it's Lenz's law taking over again here. It's saying, look, you have these downwards magnetic field vectors which are trying to get bigger in the downward sense. Lenz's law always wants to oppose that, so the induced current is going to be up like this to try to etch away and battle those increasing downwards magnetic field arrows right there. So they're going to be induced in the upwards direction because a down and up cancels a bit. The induced current is going to try to cancel out that downwards growth in the red arrows right there. So the conclusion of this problem then is the magnetic field must be increasing in strength in this red direction given.